In this sublesson, we're going to be talking specifically about quantitative variables. In this video, we're just going to explore the different types of quantitative variables that there are. The actual mathematics will be in segment 2 of this course. All right, so we saw that variables can be divided into quantitative or categorical variables. Looking at quantitative, we can split those even further and talk about discrete quantitative variables and continuous quantitative variables. The difference is that a discrete quantitative variable has specific values. For example, if I say, go look at your bookshelf right now, pick any one shelf and count the number of books you have. Some people might say, I have 5 books, I have 10 books, I have 40 books, I have 37, I have 22, I have 6. Notice that every answer is a whole number. Don't you have 3.7 books? 17.9 books? I mean, yeah, I'm sure you could get technical and say parts of book, like cover's been ripped off or something. I mean, we're talking about whole books. Okay? So you have a whole number of books. Okay? So if you didn't like that example, since I brought up, you could have a cover ripped off or something. Let's talk about pets. How many pets do you have in your home? I have 4 pets. I have 7 pets. I have 10 pets. I have 1 pet. I don't have any pets. It's always a whole number. You're never going to have 1.4 pets or 7.9 pets. It's not going to happen. That would be impossible. So specific values are possible, but the values, any number in between those two values is not possible. So, for example, the number of children, just like the number of animals, number of objects, like the number of books. Money is discrete. Now, notice there is something different here with money. If I ask you how many dollars are in your pocket, you could say, I have $2.37. Well, that'd be $2.37. You've got a fraction, a decimal. So discrete variables don't always have to be whole numbers. They can be partial numbers as well, or they can be a decimal. So cents is a hundredth of a dollar. Okay, so you've got just a small piece of a whole. However, money is always counted to the nearest hundredth. If I ask you how much money you have in your pocket, you're not going to say, I have $2.37.5. That half cent doesn't make sense. Sorry, that's a bad pun. Oh well. So fractions of a cent, they don't make sense anywhere except for at gas stations. For some reason, they still charge 9/10 of a cent. However that works out. Anyway, so money is a discrete variable. You personally will never handle a fraction of a cent, which would be 1,000th of a dollar. That's never going to happen. Time, according to a clock, is discrete. And by according to a clock, if I ask you what time is it right now, you'll say, oh, it's 9:35 and 7 seconds. Okay, so you've got a very exact number. You're never going to report 7.5 seconds or 7.76739274 seconds, right? The decimal is not going to happen. So time, according to a clock, is a discrete variable. Now, hold on to that thought. We're going to come back to time in just a second. That's discrete variables. Continuous variables, any number is possible. You can have any number on the number line. Pick one, it doesn't matter. Here's an example. Weight. So let's pretend like I am 165 pounds. And I have my friend over here who is also 165 pounds. Are we both exactly 165 pounds? No. I could be just a fraction of a pound higher. He could be a fraction of a pound lower. So, and you can have 100 people who have a weight of 165 pounds, but every one of them is slightly different, and so technically they're all different weights. Height is the same idea. So any value is really possible for these variables. Area, well, say the area of a desk or the area of your property or whatever. Distance, how far is it from your dorm room to your classroom? If you're online, that may be the same thing, right? Anyway, distance is a continuous variable. You can stop at literally any distance. Any distance is possible. And then finally, exact time. What is the exact time right now? I'm not talking about according to a clock. I'm talking about a very, very, very precise instrument to measure time. It could be 9:37 and 7.6372943764777732 on and on seconds. Okay? So any number really is possible. Perhaps with this time example, you're going to see this most often in, say, a science lab, a physics or a chemistry lab. If you're timing a reaction or timing an event, how long will it take for this event to happen? It could be any time. You can have decimals that go on forever. Okay, those are your two different types of quantitative variables, discrete and continuous. In our next video, we're going to talk about the different levels of measurement.